All right, so local maximum. Absolute maximum. This since it's closed in interval, this is it happens at S there. Absolute minimum R. Local maximum, there is another one here. It's a C, so an S. No, it's just a C, because local maximum you need the increase and decrease. When it comes to S, it doesn't do that. Local minimum, yes, here it does. You need a decrease and increase, so near it, and the same thing here. So B and R, it does that. Neither a maximum nor a minimum. So for example, A and D. For this one, you just pick a graph that matches the criteria, and this graph matches this criteria of having F continuous 1 to 5 and has the given properties, absolute maximum at 5. Yeah, so this is the absolute maximum at 5. And second one, absolute minimum at 2. So if we get to 2 here, we'll find that's the absolute minimum, yes. Local maximum at 3, there is an increase and decrease, this one here at 3, so yes. Local minima or minima at 2, yes, it's there. The absolute is also serving as the local there. And 4, it also near 4, it happens to have a local minima. So that graph matches there. So for number 6, find the critical numbers of the function, and I'll copy it down. F of x is 6x cubed minus 9x squared minus 36x. So to find the critical numbers, we need to find that first derivative. And we do 6. And here you'll do 3x squared minus 9. And here you do a 2x. And here a 36. So 18x squared minus 18x minus 36. So we can factor 18 x squared minus x times 2, and we set it to 0. 18 times x squared minus x minus 2 equals 0. 18 is not 0, so the zero product property, 18 is 0 or this is 0. 18 is not 0, so this must be 0. So factor, we need two numbers multiplying -2 and add, we get -1. So it's a 2 and -1. So these must be the critical values. All right, so these are the critical numbers. Now, a similar question for g of t, and you have the absolute value. So this is a nice example to refresh and reinforce the definition of absolute value. So this absolute value, for it to be positive, you have to consider two cases, of course. This 4t minus 3, of course, is the answer. That's if for t minus 3 is positive. If that quantity is positive, then it's the same thing. However, if that quantity is not positive, then you need to use the opposite, because that's how the definition of absolute value works. So the absolute value of A is A if A is positive, but if it's, let's show it here. If A is positive, if it's negative A, if A is negative. This is usually not easy to see, but if you switch it to numbers, it makes sense. The absolute value of negative 5, right? The answer, since it's negative, it means this one. So your answer cannot be negative 5, so you have to do negative. If A is negative, it's one side is negative, then you have to do the opposite, which will give us 5, right? And the other case is this one, 5. If A is positive, then it's just the same thing. So that's how to understand it. And similarly, we apply it here. If the inside is positive, then it's same. If it's not positive, then you gotta switch it. So if for t minus 3 is positive, negative for t plus 3, if for t minus 3 is negative. And so similar idea here, if you take the g prime, the derivative for each one, it's a 4 and negative 4 for this one and this one, if you do g prime. Of course, what does this mean? If you solve this inequality, means t is greater than or equal 3/4. And here t is less than 3/4. So because this is what we did in the past, because these are not the same, so the derivative does not exist at t equal 3/4. However, this 3/4 is a critical number. And when you graph this, that's going to be the lowest point of that vertex. So for number 9, similarly, we need to find the derivative to find any critical value or number. So we need the sine theta. We need the chain rule for this one. Sine theta times its derivative. And that's a 12. And now for the derivative to be 0, it means we need to solve this. Negative 12 sine theta equal negative 12 sine theta cosine theta. So divide by negative 12 both sides. That's just gone. One issue happens in this one is to cancel sine. Here to put a note, cannot divide by sine theta because it's not a fixed number like negative 12. So the solution here is to bring it over just like we usually do, and we will factor Then we'll say the zero product property gives us this. So what does it mean for sine theta to be zero? On the unit circle, it happens at, for example, 0. It happens at pi. It happens at 2 pi. So it happens at every k pi. What does it mean for cosine theta equal 1? This means that theta has to be on the unit circle to be 0, to be 2 pi, to be 4 pi. And of course, with the negative numbers as well. So if you compare these two, you'll find that this one includes this one. So we can just summarize and say Kn. So here, since solution of sine theta equals 0 includes solutions of 1 minus cosine theta equals 0, we can adopt solutions of sine theta equals 0, which is pi n right. All right, we can try this example. So now we can use that method of looking at this example here. We have a function and we can differentiate this function, and you're going to find that it's, of course, you can switch it to x plus or x negative 1 and differentiate, and you find that it's, try it and you should get something like this when you do the common denominator, x squared. So for f prime of x to be 0, you set it to 0. That means x plus 2 and x minus 2 equals 0. The denominator is 0. The numerator is 0. The denominator cannot be 0, right? So numerator is 0. So now, of course, numerator is 0, denominator cannot be 0. Or you can set it as proportion cross multiply and you get the same thing. So now what we need to compare, we have a 0, 2, not that way. We have a 0, 2, 8 interval, and we have a negative 2, 2. Negative 2 does not belong to this interval. It doesn't exist there. So we will take 2 since it is in 0, 2, 0, 2, 8. So now we can find f of 0.2, and we need to find f of 8, and we need to find f of 2, and we compare them, right? So that's the idea here of these minimum and maximum values on the closed interval method, right? So f of 0, 2 gives us 20.2. F of 8 gives us 8.5. F of 2 gives us 4. So what does this mean? 20.2 is the highest. So that's a maximum value. And comparing a 4 with the 20 and 8.5, this is the absolute minimum. So this should be the absolute maximum for this interval. So we can summarize, these notes, and there isn't much really other than just to understand the difference between the absolute and the local, finding the first derivative, and finding the critical values, and that's all. And if you use this method we talked about here of closed interval methods, then it gives you the absolute max and minimum on the interval AB. All right, thank you.